Welcome back to another video of Linux Hardening series. In this video, we will be installing Fail2Ban, an intrusion prevention system that helps protect Linux servers against brute force attacks. Attackers often use automated bots to repeatedly guess SSH passwords until they gain access. Fail2Ban monitors authentication logs, detects multiple failed login attempts from the same IP address, and temporarily blocks that IP using the firewall. Installing this tool adds an important layer of automated defense and is a standard security control used in enterprise Linux and cloud environments.
Let's install Fail2Ban by executing the command sudo apt install fail2ban-y. Sudo executes the command with administrative privileges. Apt, Ubuntu's package manager used to install software. Install downloads and installs the specified package. Fail2Ban, the intrusion prevention software being installed. -y automatically answers yes to installation prompts, making the installation non-interactive. In enterprise environments, internet-facing servers are constantly targeted by automated bots attempting brute force attacks against services like SSH, FTP, and web applications. Fail2Ban continuously monitors log files for repeated authentication failures using predefined filters. When the number of failed attempts exceeds a configured threshold within a specific time window, it automatically creates a temporary firewall rule to block the attacker's IP address. This automated response significantly reduces unauthorized access attempts, protects critical infrastructure, lowers security risks, and complements other security controls such as SSH key authentication, firewalls, SIEM platforms, and endpoint detection solutions.
Fail2Ban is now installed, but it's important to verify that the installation completed successfully before moving to configuration. In enterprise environments, we never assume a package installed correctly. We always validate it. To verify the installation, we will execute Fail2Ban client-version. This step confirms that the Fail2Ban client is available on the system and shows the installed version. Verifying installations helps identify issues early and ensures we're working with the expected software before enabling security protections.
Now I'm enabling and starting the Fail2Ban service. Installing a package doesn't automatically mean it's actively protecting the system. So we execute sudo systemctl enable Fail2Ban. The enable command ensures Fail2Ban starts automatically every time the server boots, maintaining continuous security without manual intervention. And then sudo systemctl start Fail2Ban. The start command launches the service immediately so it can begin monitoring authentication logs and blocking suspicious login attempts. This is a standard practice for all critical security services in enterprise environments. Now that the Fail2Ban service is running, I want to verify its status instead of assuming everything worked correctly. In enterprise environments, every critical security service should be validated after installation and startup. So I'll execute sudo systemctl status Fail2Ban. This command shows whether the service is active, confirms it started successfully, and displays recent log messages. Verifying the service ensures Fail2Ban is ready to monitor authentication logs and protect the server against brute force attacks.
Now that Fail2Ban is running, it's time to configure it. Instead of editing the default jail.conf file, I'll create a local configuration file named jail.local. This follows enterprise best practices because the default configuration may be replaced during software updates, causing custom settings to be lost. So I'll execute sudo nano /etc/fail2ban/jail.local. This creates a separate copy where I can safely customize Fail2Ban while preserving the original configuration, making future upgrades and troubleshooting much easier. Now I'm editing the custom jail.local configuration file to define how Fail2Ban should respond to suspicious activity by executing sudo nano /etc/fail2ban/jail.local. This is where we configure important security policies, such as how many failed login attempts are allowed, how long an IP address should remain blocked, and the time window for detecting attacks. These settings directly affect the balance between security and usability.
Enterprise security teams carefully tune these values to stop brute force attacks while avoiding unnecessary blocks for legitimate users who may occasionally mistype their passwords. We'll set the ban time equals 1 hour, blocks an attacking IP address for 1 hour after it exceeds the allowed number of failed login attempts. Find time equals 10 minutes. Fail2Ban counts failed login attempts that occur within a 10-minute window. Max retry equals 5. If an IP fails authentication 5 times within 10 minutes, it will be banned. Enabled equals true. Activates protection for the SSH service, so Fail2Ban monitors SSH authentication logs and blocks attackers automatically.
Now that I have completed the Fail2Ban configuration, I need to reload the service so it applies the new security rules. Linux services do not automatically read configuration changes after editing files, so I'll execute sudo systemctl restart Fail2Ban. Restarting the service reloads the updated jail configuration, activates the SSH protection rules, and ensures Fail2Ban starts monitoring authentication logs with the new detection and blocking policies. This step is critical because an incorrectly reloaded security service can leave the system unprotected.
Now that I have restarted Fail2Ban, I need to verify that the service is active and running with the new security configuration. In enterprise environments, we never assume a security control is working just because a command completed successfully. So I'll execute sudo systemcontrol status Fail2Ban. This command confirms the service state, checks for configuration errors, and displays recent activity logs. Verifying service health ensures Fail2Ban is actively protecting the server and ready to detect unauthorized login attempts.
Now that Fail2Ban is running, I want to verify that the SSH jail is active and protecting my server. A jail is a monitoring rule that watches a specific service, such as SSH, for suspicious activity. So I'll execute sudo Fail2Ban client status SSHD. This command displays the SSH jail status, including the log file being monitored, the number of failed login attempts, and any currently banned IP addresses. Verifying the jail confirms that Fail2Ban isn't just running, it is actively enforcing our SSH security policy and ready to block brute force attacks.
Now that I've confirmed the SSH jail is active, it's time to test whether Fail2Ban is working as expected. In enterprise environments, security controls are always validated through testing rather than assumption. Before testing Fail2Ban, we need a way to generate failed SSH authentication attempts. In our previous Linux hardening video, we disabled password-based SSH login and switched to SSH key authentication for better security. Since password authentication is currently disabled, there won't be any password login attempts for Fail2Ban to monitor. So, for demonstration purposes only, we'll temporarily re-enable password authentication. First, I'll open the SSH server configuration by executing sudo nano/etc/ssh_config.inf. Inside this file, I'll locate the line password authentication no and change it to password authentication yes. If the line is commented out with a hash symbol, I'll uncomment it and set the value to yes. After saving the file, I'll reload the SSH service by executing sudo systemctl restart SSH so the new configuration takes effect.
Now, password authentication is temporarily enabled, allowing us to intentionally generate failed login attempts and observe how Fail2Ban detects and blocks brute force attacks. Once we've completed the demonstration, we'll restore our secure configuration by disabling password authentication again. You can follow the Disable Password Login video in this Linux hardening playlist to switch back to SSH key-only authentication, which is the recommended configuration for production and enterprise servers. I'll intentionally generate a few failed SSH login attempts using an incorrect username or password. Then I'll check the SSH jail statistics to confirm that Fail2Ban detected the failures. This verification ensures our intrusion prevention system is monitoring authentication logs correctly and is ready to automatically block brute force attacks when the configured threshold is reached.
Now that I've generated multiple failed SSH login attempts, it's time to verify that Fail2Ban detected them. I'll execute sudo Fail2Ban client status SSHD to view the status of the SSH jail. This command shows the number of failed login attempts, currently banned IP addresses, and the list of blocked IPs.
If the failed attempts exceed the configured threshold, my IP will appear in the banned list. This validation confirms that Fail2Ban is actively monitoring authentication logs and automatically responding to brute force attacks. In enterprise environments, security engineers always test and verify security controls after deployment to ensure they are functioning correctly before trusting them to protect production systems.
Now that I've verified Fail2Ban is detecting and blocking suspicious login attempts, the next step is to examine its logs. Security logs provide detailed information about detected attacks, blocked IP addresses, and service activity. I'll execute sudo tail tacf var log fail2ban.log to monitor the log file in real time. As new events occur, they'll appear immediately on the screen, allowing me to see when an IP is detected, banned, or unbanned. Reviewing logs is an essential skill for security engineers because it helps validate security controls, investigate incidents, and troubleshoot configuration issues in production environments.
We've successfully verified that Fail2Ban detects and blocks brute force attacks. Since we temporarily enabled password authentication only for testing, it's important to restore our server to its secure configuration. I'll disable password-based SSH login again and continue using SSH key authentication, which provides significantly stronger security against credential-based attacks. To avoid repeating the same steps, you can follow the Disable Password Login video in this Linux hardening playlist. Always remove temporary testing configurations before moving a system into production, as leaving them enabled unnecessarily increases the server's attack surface. That wraps up our Fail2Ban setup and testing. If you're enjoying this Linux hardening series and finding it helpful, please subscribe to the channel, and don't forget to like this video. Your support helps me create more hands-on cloud security content.